So today we're talking about the applications of sinusoidal functions. And hopefully by the end of the period you will be able to model real life situations with sine and cosine functions. To create a cosine function for your data, you need to know these four pieces of information, just like before. The amplitude of the function, the vertical translation, horizontal translation, and the period. Now the sine function has the same period, vertical translation, and amplitude, but its horizontal translation is 1/4 of the period to the left of the cosine curve. So if it doesn't tell you how to write the function, it's usually a lot easier just to default to your cosine function. Okay? It's easier to default to your cosine function. However, if you have to write a sine one, just remember that everything else is the same: amplitude, vertical translation, the period, and then just the horizontal translation is 1/4 of your period to the left. And so with the application problems, that's pretty much the bulk of the notes. Okay, you're gonna get your experience with actually doing multiple types of problems. Okay, so these involve anything from a Ferris wheel to the motion of a buoy, to modeling temperatures over time, to a roller coaster, to the sky's the limit. Okay, so you're gonna see all the light. All right. Before we get to an example, not every time will you be given a graph that you're going to look at and try to figure out the amplitude. Okay, not every time you're going to be given an equation. You yourself would actually have to create the equation. So it might be helpful to know that amplitude is associated with what variable?
A.
A. In the general form. What's the general form?
The absolute value of A.
No, I mean like of any sine or cosine function. What's the general form? Is y equals sine or cosine? Bx plus c. It's good to know that form. Know that amplitude is A. And so whatever the amplitude is, we're going to plug in there. And sometimes, depending on what we're given, it's also good to know that the maximum minus the minimum divided by 2 can also give us the amplitude. Okay? Because remember, the amplitude is basically half the distance between your max and your min. Your vertical translation is associated with what variable? D. And to find that, we can take our max plus our min and divide it by 2. And sometimes knowing that can actually be a lot easier than trying to, do it some other way. Your horizontal translation is associated with what variable? Which variable? C. Because it's a combination of b negative c over b. But the thing is about word problems is if we're doing a cosine function, right? Normally cosine starts where? Like if you were to graph it, the original cosine function, where does it start on your y-axis? At 0, 1, and then it goes down, right? So a lot of times, and 0, 1 is a maximum of your cosine curve. Wouldn't you agree? A lot of times we can figure out where our first maximum occurs. Say it occurs, over here instead. And we can figure out this horizontal distance, we found our phase shift. And it's simple as that. Lastly, our period. What's the formula for period? And there's the B. Okay? So all this information is going to be helpful for us when we're looking at some of these problems. And here we go. We're probably going to be able to get through 2 today. That's all right. We're going to do it today and tomorrow. All right? So we're going to use the information below, that's a left, to write a sinusoidal function that models the number of hours of daylight for New York City as a function of time x, where x represents January 15th, X equals 2 represents February 15th, and so on and so forth, okay? Then use your model to estimate the number of hours of daylight on September 20th in New York City, okay? So, we have our data here, and we're trying to write a function.
So this here.
So, where do you want to start? Huh? Let's start with our amplitude, which is A. Good place to start. I need to pretty much know where my maximum occurs. Where's my maximum occur? What's the largest value?
15.07.
Okay. And what's my minimum? What's my smallest value? December? Okay. So to find my amplitude, if we recall from the last page, it's your max minus your min over 2, right? Right?
Yes, ma'am.
Okay. Yeah. So we're going to do that real quick.
Press not our calculator.
I ain't your calculator. So about 2.9. So then, there's our A. We can take the same numbers, add them together, divide by 2 to find our vertical shift. And that is 0.17. Confirmation? Yes. All right. So we have A and D, halfway there. We need to find B and C. Okay? Now, this was your maximum value plus your minimum value divided by 2. To find the vertical shift, how high up it moved from the original, yeah, it's your midline. Okay? We can find either B or C. Honestly, the order in which you find things, it really doesn't matter, okay? Let's do our period next. Or let's do our B next, which is associated with our period. We know the period formula to be 2 pi over the absolute value of B. Okay? And in this particular problem, what do you think our period is going to be? How long do you think it's going to be before our hours of daylight start to repeat themselves? Say it again. Not 6.
12.
12.
Because
You're thinking a complete cycle because it goes up, then it goes back down, and then come January, it's probably going to end up going right back up again.
So
It is a whole period,
Yeah, that's what I saw.
which is 12. I know you said it, but I was like, okay, well, so what is it? So it's going to be 12. And so to solve for B, it's just like an equation here. What do we have to do to solve for B? Not divide by 2 pi. Multiply by B, and then divide by 12. And we'll end up getting 2 pi over 12, which is 1/6 pi, or pi over 6. So there's the B.
Can we write it as positive or negative pi over 6?
In this case, your B actually is going to end up being positive because if we were to actually create a scatter plot here, we would see that cosine is going up, then it's going back down, and it technically did not get reflected over any axes, did it? Because if this was negative, wouldn't that mean that we got reflected over the y-axis? Which means that our months would technically be negative. Does that make sense?
No.
So it is going to be positive.
So it's good. Like, in what situations would it like be?
Where B would ever be negative? None that you will encounter here.
Well,
No, it wouldn't be undefined. Like in these cases, your B is going to end up being positive. When you get to your higher level math classes, you will experience ones where B will be negative. You also experience ones where they won't be sinusoidal functions. You also experience ones where they'll be farther advanced than what a 10th grader in high school pre-cal would ever experience.
what is the difference between the sinusoidal functions and the ones we've been doing?
That's the thing, sinusoidal functions are sines and cosine functions. It's just like a general name to classify them.
So, but our sine function had negative b, right? It was like negative 3 times x or something in the parentheses.
If those were the cases, probably when we were describing the transformations, but all the ones we might have graphed before, it doesn't matter whether b is negative or positive when we're graphing them, they're still gonna be sinusoidal functions. It's just like the name that classifies sine and cosine functions together. Alright, other questions? Alright, last thing we have to do is our C. Last thing we have to do is our C, which is our phase shift. Or it deals with our phase shift. Okay? Phase shift is the formula of
Negative C over
okay? And if we think about cosine, again, cosine crosses the y-axis at its maximum point. And so we can figure out where the maximum point occurs, then we'll know exactly how far over the graph went from the original cosine function, okay? Remember, normally cosine goes like this. So we need to figure out where does the first maximum occur? June. And June is associated with what number? 6. So it moved over from being originally at 0, 1 to now being over at 6, the x-coordinate being 6. So our phase shift equals 6. We just found out that our b is pi over 6. So we're going to plug that in. And what we're going to end up doing is solving for c.
So you, based off of where the max was, minus the what?
Nope, just where the first max occurred, which is right here.
Okay, so I had 6 on the x-axis.
And so, when you solve for c, what do you get?
negative 36 over
Negative 36 over pi? You guys got negative 36 over pi?
Is that right?
Negative 36 over pi. Is that what you guys got? So c is going to be negative pi. So now we have our A, B, C, and D, and all we do is plug it into our formula.
Or do you want us to create the formula?
So it's going to be y equals A
2.9.
2.9
This is cosine?
is a cosine function. B is pi over 6 x, not plus, but minus c
Oh,
pi plus 12.17. Since it didn't tell us, it's always easier to default to cosine because you can always figure out the phase shift just based off of the maxes. And so since we did that, that's why it was a cosine function versus a sine.
So unless it says like this is a sine.
True. Then it's always easy to default to cosine. Now to estimate our model with the number of hours of daylight on September 20th, how do you think we're going to figure that out? September is what month?
9.
9. And if you look at the previous part of the
Oh, so
problem,
you just want to find the rest of the continuation of your...
no, not a continuation.
We look at 9 and then subtraction. 9 and 20 over something. Just 20.
Plug it in.
Plug in what?
9.
9, 9.
12.3.
What did X represent?
Hours of daylight.
Hours of daylight. In New York City, where X equals 1 was January 15th, X equals 2 is February 15th, so 9 would represent September what?
Oh. So what do you do like
September
9
15th.
point?
So then, what?
9?
Would you just go off to 15?
You cannot plug in 9 because I'll be representing September 15th.
We got 5 days to September.
12.40. Wait, no, what number did you plug in? What number did you plug in? 12.48. Oh. Are you getting 9.166? How are you getting 9 and 1 6? Divided 5 by 30.
Yeah, because you're just adding on.
Yeah, but you have to account for different days.
But it's September though.
Are they trying to do? Is it just complicated?
And I think y'all are too smart for your own good. That's really what the truth is.
Well,
You really are.
Yeah, it's like.
So it's not 9.1666.
Maybe it's
Thirty.
5.
Hmm? Where you getting 2/3 from? Because the 30 days is September. The only thing is that we're starting with September 15th being like the start of the 9s. I guess you would say. Are you getting 55 over 6?